M3A05 is a re-implementation of the GCD function in a recursive manner. So we have here the test harness that we used for our previous exercise, so we can use it as a starting point and modify it as needed. And what we are going to do is we are going to once again go directly to tools.c, and we are going to modify the implementation of GCD. So we are going to keep the code for the old GCD, rename it GCD iterative, okay, and we are going to define our own recursive version of this code. So let me scroll down a little. That's going to be int GCD. Okay, we have a couple of issues here displaying this. Let me try something different. I'm going to go to the end of the file and add a couple of blank lines just so that it's readable here. Okay, int A, parameter A, always the same thing, parameter B, always the same thing. We're just going to change how we compute the GCD, not what we compute, not the interface to call this function. Okay, so as always with a recursive function, we need to stop a minute and try to think about what we need to do. Well, we need to first get rid of parameters that we do not want. So this is going to be the same thing then for the iterative version. If the parameters are not correct, I get a return value of -1. Now, what do I have to do next? Well, the recursion happens when the modulo of A by B is actually different than 0. So that means that when it is 0, I can get rid really easily of the task I need to do. What I did in the iterative version, I had a variable int n, which just to make things a little cleaner, well, I'm going to put right here in front of the if. I had a variable which I used to compute and store the value of A modulo B. And then after that, what I did is check if n equals 0. If the modulo is 0, then I could return my value. Well, this is still true. And I will always do that when I'm trying to do a recursive function. I get rid of the easy cases first. So my termination case is when n is 0, I am done. Now when n is not 0, this is when I have to do some more iteration. And in the case of a recursive function, that means some more recursive calls. What do I need to return? I need to return the result of computing the GCD with A equal B, B equal N. That's what I did in the iterative version. Well, in the recursive version, it's even easier. B, the current value of B is passed as first parameter. The current value of N is passed as second parameter. So, let's save this code. So this is a straight translation of the iterative version, okay? Let's save this code here, and we're going to read out the syntax errors. There we go, and then we are going to apply our test harness. Test harness went successfully, so that means I refactored the code, I modified the way I implement it, but I didn't modify the behavior of the function. Now, once again, what I would like you to do now, and don't consider this as being an optional exercise, what I would like to do now is to trace the execution of our recursive GCD with the execution stack diagram. And once you do this, we should be done with this exercise.